Inside of a thunderstorm like this one, updrafts of nearly 100 miles per hour can lead to a tornado, or something much weirder that costs billions more in damages each year. Hail. Frozen, sometimes giant chunks of ice falling from the sky on a warm summer day.
Oh my god, that was huge!
This is the kind of hail that will come through a roof.
While it may not seem as scary as many other natural hazards, it causes over $10 billion in damage each year across the US. Today, we're going to visit a lab whose top scientists fly across the country on a moment's notice to find and 3D print record-breaking hailstones. They also use an incredibly complex potato gun to make holes in roofs. Their goal is to figure out how to decrease the damage hail causes and how hailstones get so big.
Look at the size of this piece of hail.
Hey Maya, welcome.
So, we are at your hail lab.
We are. So we are going to go make some lab hail and then we're going to go shoot it at some shingles.
But first, I wanted to know just how big hailstones can get and how they grow so large.
So this is the United States and current world record hailstone. That was found in Vivian, South Dakota. This one is the recent record for the state of Texas. These are 3D prints, and it comes in over 5 inches in diameter. And you can see it's really flat. It's very oblate. Yeah. That one's a little more round.
Yeah, I would think. I don't know. I'm sure some people think of hailstones as like perfect circles.
Yeah, that's right.
Right?
So hailstones,
these are not.
That's right. They get less spherical as they get bigger. And they start to get all these spikes and knobs and all these kind of crazy shapes. And that actually plays a role in how fast they fall and how much energy they have when they hit things.
And they do hit things. Ian told me that hail forms when a thunderstorm's updraft stretches clouds high enough into the atmosphere that the air temperature dips so low that water droplets turn into ice. And if updrafts hold them there long enough, the water droplets and ice freeze together, making hail larger and layered. When a hailstone gets too heavy or the updrafts weaken, it falls thousands of feet to the ground.
And it took a column of rising air that's over 100 miles an hour. So think about air going up at 100 plus miles an hour to keep that stone and this one aloft to be able to grow to these kind of gargantuan sizes.
And how fast are these coming out of the sky?
So this one, our record, is going to be falling at over 100 miles an hour. This kind of hailstone will actually fracture the plywood deck and perhaps even go through a roof.
In fact, hail causes so much damage that there have been efforts over centuries to stop it. 300 years ago, Europeans tried firing cannons into clouds and ringing church bells. In the US, Russia, and even Canada, cloud seeding by dropping silver iodide via plane or rocket was and still is attempted to decrease damage. But still, giant hail up to the width of a volleyball falls from the sky. So the folks at IBHS decided to work on changing the way we build rather than changing the weather. That included creating a machine to make accurate size and density hail. How accurate is the recreation of these hailstones?
So it's actually pretty precise. We've gone to the field and basically done scientific storm chasing to go make all sorts of measurements of real hailstones. So we know what the distribution of how strong they are and what their density is. And we can actually vary the density of the ice, how strong it is, so how much force it takes to fracture it. And we can dial up those knobs to basically replicate what we see actually out from thunderstorms in the real world.
That's where the hail collection comes in. By 3D scanning hailstones in the field, 3D printing them the size and weight, and flying them in a skydiving chamber, Ian and his team learned that the unusual shapes of hailstones actually act like helicopter rotors. When they grow this large, the flattened shape and protruding knobs make the stones spin, allowing them to stay aloft in a storm for up to 30 minutes, growing larger and larger. But the 2-inch diameter size hail that they create in the lab would take just a few minutes to form in the atmosphere.
We've made our hailstones, so we're gonna now take them over here. We're gonna go put our shingle panel to the test. So Terrence over here is gonna take each hailstone. He's gonna do his measurements and weigh the stone. And if it's in our specification, we're good to go. He's gonna walk over and load it up into our barrel.
Okay.
And then for this case, we're aiming somewhere in the range of 68 to 75 miles per hour.
But they're not just shooting new roofs. The lab has actually been weathering them for 20 years in a roof lawn before putting them to the test. Wait, what happened happened with that
There was
one?
our hard bounce. So that's where the stone was so strong, it just bounced right off the shingle.
Okay.
And so that's one of the impact modes we're actually targeting. So a hailstone, when it hits a shingle, can do basically three things, and it's all determined by its strength. It can, one, turn to slush, basically shatter into a whole bunch of pieces and leave that kind of snow cone little pile of ice there. That's a soft hailstone. They can shatter into a bunch of different pieces but not leave that residue. That's a harder stone that just shatters. And like we just saw right there, they can bounce off. And those are the really strong hailstones that can take, several hundred to even 1,000 PSI to actually fracture those things.
And that's what puts holes in your roof, siding, and windows. If a roof is mostly undamaged, it means their work is paying off. Even after decades of aging, it's still doing its job, often because of one revolutionary ingredient.
So some of the good performing products that we've started to see coming into the industry all have something in common. They're actually made with a polymer additive, and this is a stick of polymer material. So we're gonna go ahead and pull it, and I'll show you why this matters. So Maiya and I are gonna pull this stick of polymer. Notice how it stretches. We can stretch, 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 stretch. I'm not gonna let go because one of us will go flying, but there we go. Look how far we can stretch this.
Wow.
And if we let it go, it'll actually kind of reform to the shape it had. So we'll let this sit for a minute or two. But this is added now into a lot of the good performing shingles we see that helps give just enough flexibility to be able to handle those impacts a lot better.
What IBHS has not figured out is how to create a hail-resistant car. An intense hailstorm can destroy a vehicle, breaking windshields and denting the body. Ian's research on how hail forms will eventually help forecast which storms create large and destructive hail and which won't. But until then, here's his advice if you get caught driving in one.
Find a good spot to duck under covered parking, a gas station awning, a bank. The one thing to avoid doing is stopping under overpasses, especially on interstates. That can cause huge traffic jams. If you're caught and you have nowhere to go, just keep driving if you can, and you will get out of it. Swaths of hail have really tight gradients, so you can go from big hail to basically rain over the course of half a mile. So keep driving, keep moving. Don't necessarily sit there because you can find yourself in a slow-moving storm just getting pummeled.
Look at those hailstones.
Have you ever been caught in a hailstorm? Tell us your story in the comments below.